In our previous examples, we have used Pythagoras' theorem and SOHCAHTOA to find the size of angles and the length of sides in right-angled triangles. But what do we do with triangles that are not right-angled triangles? Well, for these types of triangles, we use the sine and cosine rules. Before we use the sine and cosine rules, we have to relate each side of the triangle to a corresponding angle. Look at this example. Here we have a triangle which is not a right-angled triangle, ABC. Each angle is marked with a capital letter. The side facing angle A is called side A. The side facing angle B is called side B, and the side facing angle C is called side C. You should notice the angles are labelled with a capital letter and the sides are labelled with a lowercase letter. When we want to calculate the size of an unknown angle, we use the following formula. The sine of A over A equals the sine of B over B, and the sine of C over C. These values represent the size of the angles, and these values represent the length of the sides. To calculate the size of an unknown side of a triangle, we use the following rules. A over sine A equals B over sine B equals C over sine C. These values represent the length of the sides of the triangle, and these values represent the size of the angles in the triangle. Here we have to calculate the size of the angle ACB, and we can use the sine rule to calculate the size of the angles to do this. The sine of C over 40 equals the sine of 55 over 18. Remember, these values represent the size of the angles, and these values represent the size of the length of the sides of the triangle. We are looking for a value for sine of C, so we have to rearrange the values to give the expression in terms of sine of C. So sine C equals the sine of 55 divided by 18 multiplied by 40. And this gives us a value for angle C of 32.76 degrees. However, we have to give our answer to three significant figures. Therefore, the size of the angle for angle C is 32.8 degrees. In this example, we are going to use the sine rules to calculate the length of side B. Remember, to calculate the length of a side, we use A over sine A equals B over sine B equals C over sine C. So using the values from our triangle, we can say that B over the sine of 30 is equal to. In our task, we have to find the length of B, so we have to rearrange the expression to give it in terms of B. B equals 12 over the sine of 75 multiplied by the sine of 30, and this gives us an answer of 6.21. Therefore, the length of B in our triangle is 6.21 centimeters. Remember, these sine rules help us calculate the size of angles, and these sine rules help us calculate the length of sides. Once we identify the type of sine rule we are going to use, we will replace these variables with variables from the triangle, and then calculate our answer.